what life on other planets would look like from a scientific perspective? Well, if you lived on a planet with twice the gravity of Earth, you would come crashing down twice as hard if you fell. So, some creatures would perhaps be stronger, stockier, and with legs close to the ground. And what if there really are Martians? Well, Mars is a planet with low gravity, so think of creatures with thin, spindly legs. And if life evolved on a dense, soupy planet, then you could perhaps see creatures as big as whales or elephants, flying not through air, but through a liquid atmosphere. The human species is not at the top of the evolutionary ladder. We are not the endpoint or the goal of evolution. Odd as it may sound to some, but we were accidents. We eat and breathe through our mouths, and that means we can choke on food. That is a terrible design. Maybe aliens evolved differently and don't need to breathe through a mouth, but, like worms do, through their skin. Anything is possible, as long as it makes sense for the environment. But how do we contact them in this huge, vast universe? And what if we really do find complex life out there? Would it change our place in the universe because it is telling us that we are not alone? I am your host, Maria Anna van Driel, and you are listening to The Next Truth, where science and myth meet. And this week we are going to make an adventurous journey through the universe with Seti's Senior Director of Education and STEM Programs, Dr. Simon Steele. So fasten your seatbelts, put on your space helmets, and get rid of those outdated alien stereotypes, and let us explore our cosmic freezer like galactic detectives. Dr. Steele, welcome to the radio show of The Next Truth, where science and myth meet. Wow, the name Seti. That challenged your curiosity. It must be a joy for you to go to work and sit behind all these computers and search for extraterrestrial intelligence. I can imagine that this is a dream job for many young people and students studying astronomy. Do you see many young people showing interest in astronomy these days?
Yes, I think there is a ton of interest in children and the next generation, which is wonderful. Astronomy is one of the most accessible of sciences. It's something that everyone can participate in. It's something you can just go outside at night and see the beautiful stars or the moon, but also it has the most weird and wonderful things like black holes and galaxies and aliens. And these are exciting to everyone. So I think, you know, the three big things that people are excited about are aliens, black holes, and dinosaurs. And we take in two of the three, I think, in astronomy. You can get dinosaurs in as well, and we can talk about dinosaurs. But I think there's a fascination with astronomy. There's a fascination of where we came from, our place in the universe. This is fundamental to humanity. And I think, you know, people can use astronomy or learn astronomy to get an understanding of how science works as well. So taking an astronomy course at college or at school not only gives you an understanding of your place in the universe, but also gives you an idea of how science works. And in modern society, it's very, very important that everyone understands how science actually works and formulates ideas and solutions, especially as we now know we're going through a pandemic, which is a lot of complex data coming out. What can we trust? How do we interpret what's happening? And this is all scientific thinking that astronomy can help you with.
So we mentioned just now a few times astronomy. And you point out you can go out in the night and see the stars, and well, black holes we do not see, but
that's a bit tougher. Yep.
Yes, a pity, isn't it?
Yes.
would be a lot of fun for a lot of people to set out their telescope in the evening and watch a black hole. Unfortunately, that is not the case. It's a pity. But what is astronomy in a nutshell for young people to understand what it is, what the science is?
Yeah, I mean, astronomy is known as the oldest of the sciences. It dates back to prehistory, where early humans would look at the sky to get an idea of navigation. We can use the North Star to tell what is north, and therefore it helps just in finding your way around. The rising and the setting of the sun tells you something about the seasons and when you plant your crops and when to harvest and everything. Humanity has always been very, very entwined in the sky, and then of course as people started wondering, well, we see these moving objects in the sky, and we see the sun and some of these stars that appear to wander. The word for wanderer is planet. What makes them move, and what significance does that have? And I think that's when astronomy becomes a science, and you try and figure out why things are moving around, and that trying to understand the universe is the basis of astronomy. When you start thinking not just why things are moving, but how things are moving, it comes into the science of physics, and then there's the term astrophysics rather than astronomy. The two are used interchangeably these days, but that's trying to figure out why and how things move. Johannes Kepler, it's interesting, was one of the first astronomers to try and figure out why planets moved, and he thought about magnetism. This was before the idea of gravity, but there's a physical process to things moving. Before then, they thought, what was making the heavens move? Was it angels pushing around the planets? Was it God? Was it just something like that? But as soon as you start thinking about what physical processes are going on, you start to get into modern astronomy. The other thing actually about astronomy is that we think about it as the sky, but we live on a planet, and astronomy deals with planets. And so suddenly astronomy is not just out there, it's not just up in the sky, it's down on the Earth, because this planet was born out of a solar nebula along with the other planets and the sun, and life developed on this planet, and that life is made up of elements and chemicals made in stars and made through chemistry. So we are part of this story, and so astronomy is not just now looking at the phases of the moon, it's the story of ourselves and the history of the universe. So it's a pretty big subject.
Astronomy starts at the first inches of your front door, so to speak.
Correct. Yes. Even as you get up in the morning and you knock your glass of milk over, and then there's gravity coming into play. So yeah, it can happen much, much closer to home.
I always have thought that gravity was a part that or a topic that you learn in physics, or theoretical physics, or particle physics, and well, physics in general. And I wasn't quite aware of the fact that in astronomy, this gravity topic is also being discussed.
It's very interesting how physics has sort of usurped astronomy from the fundamental physical science, from the fundamental philosophy. And I think that happened around the turn of the 20th century when things like quantum physics and relativity, where physics became dominant. But prior to that, astronomy was the primary science. And at the very early age, if you were studying the sciences, the natural philosophies, astronomy would be the primary subject you'd be learning. And so it's a shame that it has been taken away from the center, if you like, because it is the central science. And you're right, the whole concept that the universe is dominated by this force we call gravity that gives it shape and gives it its destiny, including the creation of life on Earth.
Now, Simon, I read your CV and I read that you were from 1986 till 1988. Am I correct? A science teacher at the Marlborough School, Woodstock, UK. How did you, as a science teacher, end up with Seti?
Okay. First of all, we'll have to edit out those dates because it makes me feel so old. But
Oh, okay.
no, I'm kidding. But
I will cover that with a bleep.
you're right. My career has always alternated or has always combined science and teaching. I've always loved teaching, and I very much enjoyed after getting a degree in astronomy and physics learning how to teach, taking a degree in teaching, and working at the school. This is a small. People may or might recognize my accent. I'm from England, and I taught at this very, very nice small school just north of the city of Oxford. It was a very rural school. There were fields and everything nearby, and it was just a wonderful experience, a learning experience on teaching. What was interesting, of course, is that there was in the curriculum at school, there was no astronomy. And so I had to try and work in any astronomy I could into physics. But what there was, which is very interesting, there was a very big what was called rural studies, how to interact with the environment at this school. Now here, this poor physicist was then told to teach about, nature and things like that. But one thing that sticks in my mind is this a long time ago is one of the things that I had to teach was calculating the age of fields and hedgerows. Now a hedgerow is a hedge, plants, bushes that grow around the edge of a field, and it marks out the edge of a field. And in Europe, these hedgerows can be very, very old. They can be laid down in medieval times. And you can actually calculate how old a hedgerow is by the number of species of plants within it.
Oh,
okay. And if you take and this is, so we're getting away from science here, or astronomy, but let me you take
biology is also science,
biology,
right?
I know. So you take a length of hedge and you count the number of different plants, and roughly there's a new plant, providing you don't get sort of people coming along planting things and messing things up, which you do now. Okay. If it's a natural, just seeds blown in, built around the hedgerow, there's a new species of plant in the hedgerow every century. And so you can count out the different species that are growing in this hedge, and it gives you the age in hundreds of years. And you can calculate if it's a medieval field or if it's going all the way back, almost 1,000 years. And I'm thinking, this maybe is not very useful information, and unless you're, an archaeologist or an anthropologist. But it's very interesting to have these different ways of estimating ages, because in astronomy, calculating age and size of something so big, you can't touch anything in astronomy. Everything is done by light. How old is the universe? You can't measure it. There's no sort of clock, and there's nobody was there to write down things at the beginning. How can you use these indirect methods to work out how old the universe is or how big the universe is? And so these different methods of working things out, I found just fascinating. And there's you can work out the age of a hedgerow by counting the plants. You can work out the age of the universe by measuring how fast it's expanding, how fast things are moving apart in our expanding universe. These are just different ways of figuring out something very, very fundamental that I thought was quite cool. So yes, I really enjoyed teaching. This is a digression. That was an interesting aside. And I was thinking when you were asking me that question, what do I remember from those 2 years? And I really, really enjoyed it. I've taught a lot since then. I've not taught at a school level. I've taught at many universities in many countries. But I think that experience of working with children and it's very, very sort of fundamental ideas of learning and types of teaching has always stuck with me.
And so one day from plants, you go to planets and you end up with Seti.
Yes, in fact, Yes, and it's a zigzag path. It will take a long time. But I did a PhD research, and I was always interested not in SETI so much as the universe, as galaxies and black holes and quasars, which we can talk more about if there's time. But these are the sort of the large objects in the universe and what make the universe, they're so exciting. So that was my interest, but always, of course, in the back of your mind is the concept of are we alone? And I don't think whatever field of astronomy or science you're in, there's always a question in the back of your mind: are we alone? What else is out there? And so when the opportunity came to work at the SETI Institute, I just had to jump at it, even though my background is dealing with much larger objects. I thought, well, this is something I really have to do. And so it's very, very interesting. A lot of people at the SETI Institute are biologists, and they work with as well as SETI. But I think with my interest on a much larger scale of the universe that my research and my interests are, it puts everything into a perspective. It's very important to get things into perspective in science. And I think maybe that's given me a little bit of perspective from the large scale.
So these quasars?
Quasars.
Okay.
Yes.
Quasars. Okay.
Yeah.
What is that? Is that it sounds like as if I can buy that in the supermarket. No?
Yes, it's also a game. It's a laser tag game, but that's something else.
I'm totally into laser tag games. Yes, but what is it in astronomy?
In astronomy, let's go backwards in time from what they are to what people thought they were. They are the centers of galaxies with very, very big, called supermassive black holes. And these black holes that are a trillion times the mass of our sun, roughly the size of a solar system, are the center of these galaxies. And as material falls into the black hole, it heats up. And some of that material doesn't fall into the black hole, but it gets spun around and shot out like a Death Star from Star Wars. And these jets, this light that comes out from these black holes, it's weird that black holes are totally black, and yet they're the brightest objects in the universe because of the material they're taking in, or not taking in. Once you're inside a black hole, you can't get out, but the material surrounding the black hole becomes so bright because it's so hot. They can be seen to the far edges of the observable universe. So that's what they are. Now, when they were first discovered, they were discovered with radio telescopes because they give out a lot of radio waves.
Yes.
And they were thought to be stars because they were so far away, they were just one speck of light. And so they were called star-like object or quasi-stellar objects. Quasi means like or similar to. And that word, quasi-stellar object, was shortened to quasar. But they are giant galaxies so far away that all you can see is the very center of them. But it was first thought that no natural phenomena could produce this much light and radio waves. And so it was thought that these are signs of alien civilizations, because there's no way you can create something that is so bright from such a small area.
I suddenly have to think about Dyson spheres.
Yeah. Dyson spheres.
Yes.
Okay.
I watched. I believe it was 2 or 3 days ago, and I watched via Facebook a broadcast between you, a conversation between you and Dr. Shostak. That was also about Dyson spheres. But the thoughts in that conversation about these Dyson spheres immediately went out to space travel, for energy storing, for traveling through space, or perhaps even with warp speed crossing the universe. Now I was thinking, why would you immediately think about traveling with dense objects like spacecrafts? Why could an immense power as what people think of is being produced by a Dyson sphere has more to do with a form of communication? So if these jets are being released, is it perhaps an alien civilization, regardless the type of it, is starting to communicate with everything around itself in this particular place of the universe?
That's a very good question, because what, as I said, a Dyson sphere, should we identify a Dyson sphere, and to explain what that is to your audience, it is an artificial structure that is big enough to completely surround the star of the home world. So what you would do is you'd build something possibly the size of the Earth's orbit out of some material that would completely enclose the star. And what that means is that you could then harness the energy from the entire star, not just a little bit that falls on our little planet as it goes around the sun. To do that obviously requires a very advanced technical civilization, and we don't know yet how to do it. I mean, the concept is clear. And if we detected one of these Dyson spheres, it would be obvious that it would be created by an advanced intelligent civilization. Now, a civilization that can do that has the power to manipulate very, very large amounts of energy. And so one of the questions would be, why not manipulate a natural phenomenon that could then be modulated to create an artificial signal? For instance, pulsars are another example. These are rapidly spinning balls of remnants of dead stars that give out very, very regular pulses as they spin. Now, if you have an advanced civilization, maybe you can modulate the spin rate, and anyone then studying how fast these things are spinning with very slight variations would say, well, that can't be done through a natural phenomenon. That can only be done through artificial interference. And the same you could say for quasars, which are on a very, very different scale. If you start trying to manipulate these giant black holes at the centers of galaxies, you have to employ energies 10 billion times as great as the civilization that can even build a Dyson sphere. So these are very, very advanced civilizations. So what you'd want to do is you'd want to look at these natural phenomena and try and detect events that could not be explained through a natural variation. And that is very, very difficult to do. Nevertheless, people will do that. Now, supposing you are manipulating a jet of electrons, which is what this is, and maybe within that jet of electrons, or this radio signal, which in radio signal, of course, is what Seti does, that's coming out of a perfectly natural thing, whether it's a solar flare or a quasar, and then you embed in that natural radiation very slight variations in its frequency of the radiation coming out, which is basically what you do with AM or FM radio. You have a carrier signal of a particular frequency, and then you build into that a slight variation in the frequency that is actually the signal that humans are creating, whether it's music or voice.
So what you are saying, if it is a possibility, if it is possible that Dyson spheres do exist in an artificial manner, and that the light or the explosion we see or detect is a form of communication, that means that the thought experiment of Einstein, faster than light communication, is a possibility, is fact, if these things are real and really out there.
Faster than light is an interesting thing that is beyond. I'm actually thinking of that these are not necessarily faster than light signals. These are light signals, and what you are doing is you're detecting through the existence of a Dyson sphere or through the modulation of these jets the presence of intelligence that's letting you know, either deliberately or accidentally, that they exist. And that's a very interesting idea. Simply having a Dyson sphere, as we said, is evidence of advanced alien civilizations. So you have to be very, very careful when you see something that may look like one of these. And there was an example a few years ago. There was a star that was observed It was called Voyagian Star, and I'm sure you read about it, where this very ordinary star suddenly got very, very dimmer and very and backed up to normal, and then dimmer again and very, very bright again. And one way you could do that is to have very, very large, bigger than planetary size artificial screens moving in front of the star.
Okay.
And so this star was a possibility of a Dyson Sphere being constructed, because these large parts had moved in front of the star and blocked some of the light, so the star appeared to be dimmer. Now,
so there is evidence found in signals that this is fact, or was it more like that there was a large biological object, like a planet was crossing its path?
Correct. So this is the thing. So you've got if a planet was crossing that star, the star would get slightly dimmer because the planet's blocking some of the light, but it would only drop by a very, very small amount. Even a big planet would only drop it by a small amount. This was a huge drop in brightness, so it had to be something bigger than a planet. So then you ask yourself, this is one hypothesis, that it could well be the sign of technology, and that's very, very exciting. But looking more closely at the light, obviously the star got a lot of attention. It turns out that there are potentially other things that can do that. For instance, large clouds of comets passing in front of the star could also do it. And so this particular star is now not thought to be in possession of a Dyson Sphere in construction. Nevertheless, the important thing is it gives us an idea of what to look for. And there are now NASA-funded programs to look at stars, to look for these changes in brightnesses of stars that maybe most of them will be just getting dimmer because something's going, a planet's going in front. Maybe it's a binary star and they're orbiting each other, and that's going to change the brightness. But maybe if you look at all these hundreds of thousands of stars nearby, and of course our galaxy has 300 billion stars in it, that you will detect one where this change in its appearance cannot be accounted for by anything natural. And it's only then that you begin to move into the realm of, well, maybe we found something.
I can imagine that civilization that is that advanced in technology has the ability of creating an artificial, sphere, is also capable of manipulating natural gravity or magnetic fields, which then in turn could manipulate or contain or use the energy from that particular star. Simon, today you are Senior Director of Education and STEM Program at Seti Institute, which the Institute has approximately 100 scientists as well as specialists in administration, education and outreach. What does it mean to hold the position you have as Director of Education and STEM Programs? I mean, how does, not particularly right now concerning this pandemic, but how does a normal office day looks like?
Yes, I've forgotten what a normal office day looks like.
Yeah, it's already been a year, I believe.
It's very interesting. The Seti Institute is engaged in many, many different programs and many different education projects, which is very, very exciting, and many different ways of reaching out and telling, the world about the science we're doing, and hopefully as an inspiration to the next generation of scientists. There are a couple of major projects that we're involved with that are very interesting at the moment. One of them is working with the NASA's Office of Planetary Protection. Now, of course, the Seti Institute is not only interested in alien civilizations and, giant spacecraft, and we're all Dyson Sphere is very interested in that, but also very interested in any sort of life in the universe. And that's all the way down to the smallest microbes that may beyond the surface of Mars. Maybe they're still alive, maybe they're fossilized. And also the possibility of life around the icy moons of Jupiter and Saturn. Europa, one of the moons of Jupiter, has a very thick icy crust, but has a warm liquid ocean underneath. These are possible places where life could emerge or may well one day emerge. And it's very important that if we are going to study these worlds, when you launch a rover to Mars or launch a spacecraft to Jupiter, that you don't
Which
risk.
has been done.
Which
to
has
Mars.
been done, correct. Yeah. So we've just got a rover on Mars, which is wonderful. There have been several spacecraft that have been exploring Jupiter. There is a new spacecraft that is going to specifically explore this moon called Europa. Mm-hmm. But you don't want to risk damaging or influencing any potential life that could be on these worlds. And NASA goes through very, very stringent tests and exercises to make sure that anything that is sent to another world is not going to contaminate any life forms that could be on those planets. And that
sounds like panspermia, but then in reverse.
Sure, in reverse, but also coming back here, when you do a return sample to the Earth, you have to be careful when you bring that sample back to Earth that there could possibly be alien organisms within that sample, and you have to take the fullest precautions because you don't know. And it may sound like science fiction, but you cannot take a risk about something you know nothing about. You have to be very, very careful. And the reason I bring that up as Director of Education is that the Seti Institute not only does that support of NASA, but we also do the education and communications for the Office of Planetary Protection for NASA. So we are working very, very closely with NASA about the missions and how you keep a rover from contaminating another planet and how you keep those samples from another planet from contaminating the Earth. And that is just a fascinating experiment.
What would happen if, when the rover is coming back, that is just has landed on Mars, on the surface of Mars, and is coming back? I believe it is 2031 or 2030 it will come back. What if it is carrying a micro organism and brings back to Earth? What would happen to our species? Are we going to be influenced by that, or have we already been influenced by that? Are we Martians?
That is a question that comes up quite a lot, and of course the samples, the Mars sample return mission that you're talking about. Of course, the rover will gather these little containers of Martian soil, and then they will be picked up by another spacecraft. It's an incredibly complicated process. But of course, what you want to do first of all is make sure that the stuff in that container is from Mars and wasn't brought with the rover from Earth. And so that's why that rover has to be very clean. And then when you get it back to Earth, you want to make sure that that sample is kept as pristine as possible. So the question is there anything in that sample when you bring it back? And if there is, and you can analyze it, that is, see what the molecular structure is, that will give you an idea of whether it's related to life on Earth or not. The thing is that bits of Mars have landed on Earth for billions of years, and bits of Earth have also landed on Mars, and so there is a cross contamination of these two worlds. And if it turns out that the sample you get from Mars has a DNA structure that's related to ancient bacteria on Earth, then there's a suggestion that we're related, not that Martians and humans are separate but similar species, that there is a genuine cross-contamination, and either we are Martians or these things were from Earth. But if the molecular structure of these organisms is so different that it has nothing to do with DNA or that sort of idea, then you've got a genuine independent second evolution of life. And that's what could be very, very exciting. Because if you have a totally separate life chain
Yes,
to
yes.
everything on Earth, that means that life has emerged twice in the universe.
Yes.
And if it happens twice on 2 planets, and there are 1 trillion planets in our galaxy,
There
then
has to be
that suggests that it's
somewhere a
everywhere.
planet
Yeah.
that has still, if that is still containing life in a, well, in any manner,
Yeah.
right?
Because that
So
suddenly
which,
goes from 1 to 2, and that means it's everywhere, which is absolutely amazing. And that's the big discovery.
well, yeah, and it is scary as well because I have no idea how these life forms look like. If they are hostile, are they teachers, or so? Which forms or which life forms is SETI hoping to find? I mean, uh, do I have to think about the well-known grays, or do I have to think more in the direction of a virus or a bacteria, or perhaps even a fungi?
Hmm. We don't know, and that's the exciting and sad thing. Of course, until you do find another example of life, and that's the most amazing thing, is that every living thing on this planet is related. You know, you and I are related to mushrooms. We're related to octopuses. It's all the same life chain, which is just, that blows my mind anyway. So I think statistically, if there is life everywhere in the universe, most of it will be pretty primitive in form. The vast majority, simply because if you look at the statistics of numbers, there's many more basic organisms on our planet than there are advanced organisms. So that seems reasonable. What the more advanced organisms would look like or adapt to is a very, very good question. And of course, we don't know. But if we look at how life has evolved on Earth, there seem to be certain convergent designs that anything that lives in the water, and the water planets are everywhere, everything that lives in the water has to have the ability of mobility. So if you're a penguin or a fish or a submarine, you
It's adapted to its
adapt it
environment.
to the environment. If you're in the air, you need some sort of support when you're flying. So bats and insects and seagulls have developed a similar mechanism. Helicopters are different, of course, but other things have a similar mechanism of moving through low density fluids, regardless of the evolutionary chain. So it would not surprise me that if we find a water world and discover things living in it, that they probably will have fish-like characteristics in terms of shape, or whale-like characteristics, because there's a convergent evolution to adapt to your environment. But of course, we don't know. We don't know what anything will look like. And as far as advanced civilizations, communicating civilizations, again, we have no idea. And that is the problem, because of course, to think about communicating, we naturally have to think about how we communicate. And that's giving us a tremendous bias, because unlike all the movies that have very low budgets, they are not going to be humans dressed up in green suits with silver antennae. We don't know what they're going to be looking at. They may do. Maybe they will. Maybe bipedal motion, maybe, like Star Trek, that might be, the best optimum
Perhaps they
evolutionary state.
are. Perhaps an alien life form is more in a transparent or in a wavy thing, like when you see heat rising up from. Well, I'm just pouring in some ideas. So SETI is not quite sure for what kind of life forms they are looking for, except for microorganisms, which are most likely the general population of the universe and in other planets, on other planets. But the telescopes SETI are using,
Mm-hmm.
where are they aimed at?
Mm-hmm.
If you're not quite sure what you are looking for.
That's a very good question. And so the original SETI searches, of course, which were done using radio telescopes, because the universe is very clear in radio waves. Well, radio waves can travel much further without being blocked than visible light, which gets blocked by dust and gas and everything. So radio waves seems to be a good bet. Our atmosphere is completely transparent, so you can build the telescopes on the ground. You don't need to go up into space, so that works as well. And there are certain frequencies of radio waves that are very universal. That is, wherever you are in the universe, there's going to be hydrogen. We see that. And so any other civilization, if you think, well, if we're thinking, what is somebody else doing and looking at, this seems to be a good thing to do. And so I know that, again, that's a very human-centric view. So, but of course, originally, what do you look at? You don't know what to look at, because until 20 years ago, people had not discovered planets around other stars. People had speculated. And so what
20 years?
Well, 1995, 1996 were the first discoveries of planets around other stars. A very, very recent discovery.
According to my memory, but probably I'm too old to to have a correct memory of my youth. I always thought, that planets and moons are always around. Moons always around planets, but like I said, probably I'm a dinosaur.
No, you're absolutely right. And even, Giordano Bruno in the 16th century said that he believed that there were planets around other stars and that living beings were on those other stars, and that got him into big trouble, got him killed in the end.
That I didn't.
Giordano Bruno was declared a heretic by suggesting that there was life on other planets around other stars. Because that raises a lot of theological issues. So the idea of planets around other stars has been around for many, many centuries. Nevertheless, the first discovery that they actually are there was in the 1990s, which is so recent. And now we know we've discovered thousands of planets orbiting other stars. And statistically, that means that pretty much every star in the night sky has at least one planet. So there's a lot of planets out there. But before then,
I'm experiencing a realization of the Mandela effect, but that is psychology. So my memory is absolutely not correct here. Okay, fine, but please continue.
Okay. So you're right. What do you look at? Well, probably the best thing to do is look at the Milky Way. Which is a cross-section of the galaxy we live in, because that's where most of the stars are. And you would just sweep the sky. You'd look at different regions and you'd hope you detect something. That's a reasonable thing to do, but it's not very efficient, because the chances of you catching anything, you have to be looking in the right place at the right time. Now, which is great, is that now we know where a lot of planets are, and you can actually target your searches on particular stars because you know that the planets are there. The star I was talking about, Voyagian Star, which had this weird light drop, which probably isn't a Dyson Sphere. But of course, you point your radio telescope at that and you see if anything's coming out. You point your telescopes at the nearest stars, Alpha and Proxima Centauri, to see if there's any signals coming from there. So you can target your search now, because we know where the planets are. Now, that's assuming, of course, that life emerges on planets. And again, we are looking at this from our perspective, but it seems reasonable. There may be life may emerge out of dark energy. The universe itself may have a conscience. None of that can be ruled out, but finding a way to communicate on that level is probably not easy. So what we need to do is look at the low-hanging fruit and to search for planets similar to the Earth with a similar biology, chemistry, carbon, oxygen, nitrogen, which is everywhere. We know it's not like we're made of rare stuff. That seems to be a good first approach. So you can actually target your searches now to particular planetary systems that you know. But there are other things you can do as well, because remember a few years ago there was an asteroid called Oumuamua that came through our solar system. This was a rock that actually was from interstellar space, from another star system, and there was a possibility. It's weird. Where did this rock come from? I've never seen it before. It was a weird shape. It went around the sun and disappeared out into interstellar space again.
Is that with a skull-shaped rock?
It was a cigar. It's difficult to tell what the shape was, but of course, what you'd want to do is, point a radio telescope at that. Was it transmitting? Is this just a rock, or is this a probe going through our solar system? Now, it turns out it was probably a rock. You can't prove anything. There could be a spacecraft disguised as a rock, but how can you tell that? Nevertheless, what you need to do is start looking for these strange things that are outliers from normal behavior, things that are not quite explainable. And these slight changes in behavior from normal are the things that you'd want to look at. And that's what
I can imagine that the telescopes of Seti also pick up radio frequencies or any other frequencies from our own atmosphere.
Yes, that's right. And what you need to do, of course, there's a lot of things. You're picking up people's mobile phones all the time, so you have to be careful to get rid of these things.
Let's say we are looking at extraterrestrial life forms as being different than we are, and have the ability to communicate on an intelligent manner. Now, what if alien life form has this ability to reflect our own frequencies, our own radio waves, as a form of communication, that this is their basic way of communication? So there could be, but hey, I'm just guessing here. It could be that when SETI's telescopes are picking up our own frequencies, that is a reflection of an alien life form. But this is just a wild guess, this.
It's interesting, and Carl Sagan's book, and Carl Sagan was one of the early founders and supporters of the SETI Institute, wrote his book Contact. The first signals were a return transmission of early television transmissions that was received by the alien civilization, and embedded within that with a sublayer of an extra, more sophisticated communication. And that's
in mathematical designs, I believe.
Right. Yeah. That's right. So it's an interesting idea. One of the things you want to do, of course, we're getting a signal from an alien civilization that may well be a radio signal. That maybe they want us to listen in, and so they beam a radio telescope, a thing to us. Seems reasonable. We're not that advanced as a civilization. If you want to contact the recent recent arrivals into the sort of the interstellar gang, then you'd use radio frequency. But you'd never be able to figure out what they're saying, because if you were speaking German to me now, I would not understand, and we're very closely related. So the chances of actually understanding what is being said is so remote. Nevertheless, if you started speaking to me in German, I would know that you are communicating, because there will be a syntax rhythm from you. So I may not know what you're saying. I pick up the sound, and I'd be able to say that there's a communicating intelligence there. Even though I have no idea what you're saying, I'd be able to pick up patterns. There'll be certain words that you would use more than others. And so I begin to pick up a pattern. And so what you'd want to do with an alien transmission is to pick up patterns that would tell you that something, you wouldn't decode it, but you would know that something is there. Okay. And that goes back to any radio transmission. So, we were talking about quasars and radio waves from these black holes. We know that hasn't got a message in it, because it's just a signal. But if you analyzed it, maybe within that beam, there would be a modulation that would be artificial. Now, that's never been discovered, but that would be a way of telling that there is a communication going on, even though you may never figure out what they're saying.
That is so cool, really. I want to work with Seti. As I mentioned in the beginning, sweeping the remote corners of the universe and decoding its secrets is a dream job for many of you who are listening right now. All these questions about what else is there in the universe besides our own solar system. Are we alone or not? Are there other planets which look like Earth? How do aliens really look like? And are they willing to respond to our signals we send into the universe. I can imagine that after hearing Dr. Steele talking about all these amazing opportunities SETI has to offer, you would like to know if you also can become an employee at the Institute. So let's ask Dr. Simon Steele. Dr. Steele, straightforward. How do we become an employee at SETI?
Well, you can't have my job for a start because I'm enjoying it too much. But most most of the employees are research scientists, and of course, to become a research scientist, you need to finish school and go to university and probably get a more advanced degree. The fact that the SETI Institute covers such a wide range of subjects, everything from planets, Mars, to looking for biology, cosmology, to actually building spacecraft, so engineering. There are lots of very different ways that you can become involved, depending on what you're interested in. But choose a science that fascinates you, and chances are the SETI Institute is doing that, and then you can apply, for a grant to fund what you want to study, and that's what most of the employees do there because they're research scientists. But there's also a very, very dedicated team who are graphic designers, who are educators, who design websites, and who try and interpret the science as I do. I have a foot in both camps. I'm a research scientist and I'm an educator, and therefore I get to work with both groups and take all these amazing ideas and try and make them a bit more understandable to everyone. So it's a small organization, but there are lots of different ways you can join.
Simon, do you have any additional advice for young people and fresh students who like to study astronomy? What gives them the opportunity, among others, to explore the remote corners of our cosmic freezer?
I think the most important thing is curiosity, and work very, very hard, learn as much as you can in school. There are lots and lots of different ways you can get involved in space exploration, as we see from looking at the NASA rover landing. It's not just the astronomers who are going to read the data. People have to design those spacecraft. People have to code the computers. People have to design the parachute. There's people who know about fabrics. So there's a huge different range of careers that you can possibly get involved. So, but the curiosity and if you love what you do, and if you love space and love exploration, then there's always an opportunity to work at either the SETI Institute, maybe not, but other institutes around the world and other centers around the world. So yes, if you love the idea, which I did as a kid, I was just fascinated from an early age and always wanted to study the universe. And I'm very lucky that it happened. But, just keep with your dreams.
Be creative, have fun with studying, and work hard. And perhaps you will end up with SETI.
Perhaps.
Yeah. Perhaps.
It's a
Simon,
good place to be, but there are lots of other good places to be too.
I can imagine. I think so. Yeah. Simon, I see that we are past the hour. Therefore, I'd like to thank you for the opportunity to talk with you. But before we close out, can you tell us where we can find more information on SETI's involvement in STEM subjects, your research perhaps, for how people to contact you when they have questions for you?
Absolutely. And the best place to go is at a website, which is seti.org, seti.org. And that will lead you to the scientist page where you can look up and read about the scientists and their background. So that'll be a great place to start. You can read about the latest news and events. We have podcasts, radio shows, we have live talks on Facebook, and all of our talks are stored on YouTube. So you can search for SETI on YouTube and all of the talks are there for you to watch. And please do send us a message. There are email addresses as well there that you can write to us if you have any other questions. But yes, come to our website and find out more.
Thank you all for tuning in this week on The Next Truth, where science and myth meet. Make sure to visit our website www.nexttruth.com. That is nexttruth, all in one word.com. And let us know what you think about our podcast. While you're at it, if you found value in this show, we would appreciate a rating on our website in the section The Next Truth Podcasts. Or if you would simply tell a friend about the show, that would help us too. I am Maria Anna van Driel with The Next Truth. Be sure to tune in next week for our next episode.